Welcome to my projectbazaar.com. Now let's see about tampering detection in compressed digital video using watermarking. Now let's see about the abstract. In this paper, we propose the new technique of watermarking in video domain. For video watermarking, initially we separate the frames from the video. After this, it will go to the watermarking process. First step of watermarking is we apply the wavelet transform to the selected frames. The information is embedded using LSB method. LSB stands for least significant bits. It is the bit position in a binary integer giving the units value that is determining whether the number is even or odd. Then inverse transform is taken to reconstruct the images. Next part is watermark detection. If we done in the receiver side, it is the reverse process of the embedding technique. Robustness against many attacks with a wide range of changes is achieved, and also we implement the H264 AVC encodec in our process for transmission. Initially it will be quantized by the transformer. Entropy encoder is used to generating bits. The bits is given to the decoding process to regenerate the frames. It assigns a unique prefix free code to each unique symbol that occurs in the input. These entropy encoders then compress the data by replacing each fixed length input symbol with the corresponding variable length prefix free output code word. This is the flow of our process. Here we have to given the input video. For the input video, we are going to embed the information. Initial step is frame conversion. In this, we are converting a videos of frames. A film frame or video frame is one of the many still images which compose the complete moving picture. Individual frames are separated by frame lines. In special effects or animation film, the frames are often shot on at a time. After this, it will go to the wavelet transform. Wavelet transform is one technique which is used to transform an image to spatial domain to frequency domain. It will separate the images as different subbands such as approximation, horizontal, vertical, diagonal. After this separation, we are going to embed information by the use of LSB embedding. LSB stands for least significant bits. The least significant bits, it's the bit position in a binary integer giving the unit values that is determining whether the number is even or odd. It is sometimes referred to as the rightmost bits due to the convention in positional notation of writing less significant digit further to the right. It is analogous to the least significant digits of a decimal integer, which is the digit in the ones position. The least significant bits are the bits of number of closest to, and including the least significant bits have the useful property of changing rapidly. After this LSB encoding, it will go to the inverse transform. Inverse transform which is used to produce the images in the original form. After in this domain, we are going to embedding the images. For that images also we have to extract wavelet transform. The transformed coefficients are going to embedded with the selected frames. After this, we are going to produce the watermarking video. In that watermarking video, we are going to insert a embedded frames. Now let's see the demo of our process. Here I am having main.m file. Select this file, right click and run the file. This is our guide design. So initially we have to give only input video. We have selected the one video as an input. The selected video will be readed and the readed informations are displayed here. And then we go for the frame conversion. Here we are separating the each frames from the video. We got to select the one message. Now I am selecting on images. this image going to be embedded with that video. Now we go for embedding process. For embedding the images, initially we have to select a cover frame. This is the cover frame. This is the center frame of the video. And then we go for the wavelet transform. So red, green, blue, three channels are separated in the both images. This is the approximation. Horizontal, vertical, diagonal informations are separated. And then we go for the LSB embedding. LSB embedding will be done on the approximation images only. And then these images going to pass to the inverse transform. This is the inverse watermarked image. This image contains the message. This image going to be embedded with the video. Now we are going to extract the watermarked video. This is the watermarked video of the given input. And then we go for encoder. For encoding the information we have used H264 encoder. And then we go for next. We have to go into the decoder. This is the result of the decoded result. And then we go for the extraction. Here we are extracting the message from the decoded image, and then we go for the reconstruction. This is the reconstruction. Here we are taking the inverse transform to getting the original image, and then finally we have analyze. PSNR MSE values are calculated. This is the comparison between the both existing and proposed system. This is the PSNR value between the existing and proposed system.